Hi, this video will demonstrate how to do regression in Excel. So the first thing you want to enter is your data. So here I have chirps in minute versus temperature. Typically you'll enter your X variable first, followed by your Y. And then you're just going to use your data analysis tool pack. You should have inserted this at the very beginning of the semester. So I'm going to click on data. Okay, and you look to the far right. If it's inserted, you should see it here. If it's not, then please refer to the videos in either the first or the second week on how to insert that. Or let me know and I'll help you. There's a video available. You're going to select regression, okay, because that's what we're doing. Click OK. And then you input your Y. Notice these are a little backwards. So you're going to input your Y here, and Y typically is the second thing we enter. It is typically our dependent variable. And then we're going to enter our X, which is typically in the first column, or our independent variable. Okay, and then that's pretty much all you do. You select OK, and Excel does the work for you and generates a regression curve. Okay, so I know this is a lot of information. What are you really interested in? The main thing you are interested in are these two cells here. Okay, let's color those. All right. We're interested in those two cells, and then we're interested here in this cell. Okay. This cell is going to be your R that they asked for, or your correlation coefficient. It's going to be located right next to the multiple R. Keep in mind the sign might not be right. The sign of this cell should equal the sign next to your X variable. This is going to be your slope. So if this will always come up positive in Excel for some reason. It can, however, be negative. So you want to look down here and make sure the sign of those two things match. So if this is negative, that should be negative. If this is positive, that should be positive. All right, and then you're interested in these two cells. The number here next to intercept is your intercept. So remember that our equation of a line is y equals mx plus b, or I think in this book it's y equals, I think they would say b naught plus b1 x, something similar. Okay. Your intercept is either b if you think about it this way, or b naught if you think about it this way. So you're going to always answer in the equation of a line. So y equals, typically in Course Compass they're going to ask you for that intercept number first. That in this case would be 19 point, and they want 4 decimal places, 4575. Okay, and then you're going to say plus, and then the x variable 1, that is your slope. In other words, if you're using this equation, it's going to be m. If you're using this equation, it's going to be what you fill in for b1. So I would answer 19.4575 plus 0.05, and in this case, when I go to 4 decimal places, it becomes 0590, and then I put an x next to that. Okay, so your answer should always be in the form of an equation of a line, which would be y equals some constant, which you'll find that in your intercept box, plus the slope, which you'll find that next to x variable 1 times x. The only other thing you'll have to do is test to see whether or not your correlation coefficient is significant. To do this, you will refer to page 790, Appendix A, or Table A6. It says critical values of Pearson correlation coefficient. The only thing you need to know are your number of observations. In other words, this time we had 5 observations. You can count on 1, 2, 3, 4, 5, 6. So we had 6, sorry. All right, so you go down to 6. At a level of 0.05, my correlation coefficient needs to be greater than 0.811. I'm getting that off of that table A6. Because 0.9887 is greater than 0.811, then I do have a significant linear correlation. So if I want to make a prediction, I can plug in for my X here and spit out Y. All right, in other words, I can, if I wanted to know what the temperature would be if there was 900 chirps, then I could plug in for X and spit out Y. In other words, it's going to equal 19.4575 plus 0.0590 times 900. Okay, I would predict that the temperature is 72.56 degrees. If your correlation is not significant, in other words, your value is not greater than the value you look up on table A6, then you will just use the mean. In other words, my best prediction of the temperature would just be the average of all of these numbers here. Okay, so 78.77. If your correlation is not significant. If it is significant, which it is in this case, using the table A6, then you have to fill in for X and make a prediction for Y. So that is how we can use Excel to generate our regression.